Hi, everyone. Thanks for coming to see me talk. I always find the beginning of a talk the hardest part. I never quite know where to start. So this time I decided to start with a story. I went to this conference called DevOps Days, and it was in Chicago. It wasn't an InfoSec conference. It was for DevOps people. And one of the guys was giving a talk, and he said, who in the crowd works in InfoSec, works in security? And my hand went up. There was a few other hands that went up. Not many of us, like 2 or 3. And then in the back of the room, I heard someone go, boo. So, so I'm sure the guy was just joking and playing around. But to me, it highlighted what these other teams think about security. We're always seen as blockers. We're the people to say, no, you can't go live, or no, you can't do your job. So I wanted to try and give a talk to change that. I wanted to make security become an enabler. I want security to help developers go live, to be able to push into production quicker with fewer issues. So I think once we can start to automate security, we can start to integrate it. And that's when we're going to start seeing security becoming more of an enabler than a blocker. So quickly, just who am I? My name's Jamal Harris. Some people know me as Jay. I'm a pen tester. I work for this company I started called Digital Interruption. We're a security consultancy, but one of the things we really try to push is this idea that developers should be in control of their own code, and that actually with better tools and methodologies, they can start to integrate security into what they're doing. I'm interested in mobile, radio, I do some reverse engineering things, and just some accounts that I think you should follow. Obviously, the top one is me. Then I run a group in Manchester called Manchester Grey Hats, where we run free workshops, compete in CTFs, run CTFs, things like that. So if you're interested in learning a bit more about cybersecurity and kind of getting more involved with the community's things, feel free to follow us. So we have a Slack channel as well. If you're not from Manchester, that's absolutely fine. We have people from kind of all over. And then DI Security, so this is the account of the company. So this is where we put out our research and blogs and things. So I've heard this quote a lot, pen testing sucks. And I've heard that from both pen testers and from developers. So speaking to some of my pen tester friends and from my own experience as well, why do I think pen testing doesn't quite work? Often it can be quite boring. If you're looking at the same applications over and over again, it stops getting exciting, right? We're looking at the same types of vulnerabilities. We're finding things like cross-site scripting, SQL injection, cookie flags not set, the same kinds of issues. So yeah, as a pen tester, I don't really want to look at kind of boring stuff. I want to do fun things. A lot of the issues we're finding are low risk. I need to highlight them in the report because there is some risks there. But at the same time, it just means I got to spend ages writing this report that no one's going to read because it's full of low-risk issues. And people aren't going to fix them anyway because, again, they seem like they're low risk. From the other point of view, from like the developer's point of view, the reports, they're padded with all these low-risk issues, right? So they're charged a fortune. They're charged a fortune for someone to come in, perform the pen test, and it's just full of all these low-risk issues. Often, the pen tester doesn't really understand the context of the vulnerability, so we might raise it as a medium risk issue, and actually it's a high risk issue. Or maybe we say it's a high risk issue, but because of the application, it's actually a medium risk issue. Because we're only there for a few weeks, so how can we really understand the application? I don't know if everyone agrees with me, but there's a lot of ego in InfoSec. I was on a test once with a colleague of mine, really, really skilled hacker and pen tester. And we were doing a code review, and we found some vulnerabilities. And my colleague starts mocking the developer. The developers, they don't know what they're doing. And the developer's sitting right behind us. So yeah, we have a lot of ego. So it's no doubt that developers don't really want to work with us. And also, I think most importantly, pen testing, as I said before, it does get in the way. We do stop development. If you're an organization, you want to release the product. Right, that's kind of the most important thing for you. You want to make money. I'm sure we've all seen something like this where pen testing is in capitals. I need the pen test report. I think this kind of highlights that our clients don't really even know what pen testing is. And in InfoSec, I think we are partly to blame. We have different ways of describing security testing, pen testing, vulnerability assessments, red teaming, bug bounties. They all have slightly different purposes, but this confuses our clients. So I want to just we'll talk about a quick case study. This company, let's call them Talk Squared. So it's a fictitious company. They have a number of applications, web applications. In this case, let's say that there's a e-commerce application, something that an attacker found a vulnerability in, maybe something like SQL injection, and managed to dump databases and access the servers and things. But we have pen testing, right? So why would this kind of company be in this situation? So this company, they have quite a traditional development approach. I'm sure people are quite familiar with this type of thing. So there's the requirements and design, things get implemented, and then they get tested. And then when things are okay, it gets deployed. So where does security come in? Sometimes it just doesn't. Sometimes there's no budget for security, and they want to have a pen test, but there's not time and there's no budget. But in this case, with this company, let's assume that they actually did have a pen test. So for me, when I'm doing a pen test, I might, if I have to be on site, I'll turn up, and often wearing a suit, so feeling quite uncomfortable. I will go through security. I'll have to be checked in. I'll meet my contacts. They'll show me where the toilets are. I'll sit down. I'll wait for some credentials. By this point, it's probably lunchtime. Let's get a coffee or something. And then finally, I can start some testing, which is awesome. And then I've got to wait for some more credentials, and then do some testing. And eventually, I leave, I write the report, and then I send it to them. Developers, whilst I'm doing this, you can see how frustrated they are every time I find a vulnerability, because they know that's one extra thing that they now need to fix. I was actually on site this one time, and the company, it was only a 2-day test, but there was 2 of us on 2 days, so a 4-day test in total. The first day, they were really welcoming. Yeah, come in, you can start testing. Then we started to find some issues. Second day, no, you can't plug into the network. So you can see the frustration on their face as we start to find things, because again, we're there to kind of tell them they're doing it wrong. The organizations feel like they're just throwing money away, really. Not only is it expensive to bring the pen tester in, but then they need to maybe redesign the application or fix the issues or pay for new developers. But for us consultants, it's all good. So let's take this fictitious application, e-commerce application. We do the pen test, and we get these kind of results. We get remote code execution, SQL injection. Prices in the app can't be trusted. It's all trusted on the client side, so we can modify that, send that over to the server, and it just lets us buy things for less money. Then maybe some high-risk issues, so lack of authentication. We can access confidential documents, XML entity injection, kind of standard stuff. Load of medium-risk issues, cross-site scripting, things used in ways that algorithms used in ways that they shouldn't. I don't know if everyone agrees that these things are medium-risk issues, but that's kind of one of the problems, right? It's very objective. Pen testing, it's quite subjective to how we rank these vulnerabilities. We might say, yeah, this is medium. Another pen tester might disagree. We do have things like CVSS to try and help mitigate some of that, but that in itself has some issues as well, because it doesn't quite capture the details that we need. And then a load of low-risk issues. So just to ask a question, who would go live given these results? Would anyone? Okay, so what if this was the difference between your company making a profit this year or not? You've got to go live on this particular date. Any pen tester in the room, I'm sure you've dealt with clients where they've had to make this decision and they've decided to go live with these vulnerabilities. There might be the assumption that they can fix it later. That's something that I hear quite a lot. We go live now, we'll fix it in the next release. Often this doesn't happen. I was on a test, I did a test once, did the test 7 months later for the same people. They didn't even know that I had done a pen test previously because the team had changed so much since then that the pen test results had just kind of been lost in someone's mailbox. So I don't think it's fair for us to say, they can't go live. What we should do is try and help them to go live and also be secure. So what's the solution to this? I think if we can help left shift security, if we can help developers understand security and perform a lot of testing themselves, beginner in the life cycle, then it's going to be cheaper for them to fix vulnerabilities. They'll be able to identify them in different ways than we can. They have their own tools and techniques, such as unit testing. They can use some of these things to help them discover vulnerabilities. So let's look at the development methodologies that we looked at earlier. I'm going to kind of group requirements to design together because it's kind of cheating, but there's a lot of overlap. And let's see how we might be able to integrate security into these parts of the methodology. So firstly, I will just say for some applications, you might decide that actually you don't need a pen test. Maybe it's an internal brochureware application. The users that use it are trusted. They're on the internal network, and to be honest, they could probably do worse things anyway. So if there's no user data, if you trust the users, if it's a low-risk application, don't spend your budget on security. It doesn't really make sense. Instead, spend your budget on things that does make sense, high-risk applications, things like fintech applications, things that handle sensitive data and payments. These are the ones that are likely to be attacked, so they're the ones that we should spend most of the budget trying to protect. And I tried to think of it with this graph. On the bottom left here, if your application kind of falls into this part, you know what? Yeah, spend some amount of budget on it, but that's not where the priority should be. Instead, the ones in the red quadrant up here should be the ones that we spend most of the security budget on, the ones we try really hard to secure. So how can we try and integrate security into those first parts? Obviously, we want to try and think like an attacker, right? That's what we want to try and train people to do. There are different techniques for this. Threat modeling, I think, is a really big one. I think if organizations start to threat model their applications as they're designing it, they can say, these are the assets that we're interested in. How might an attacker get there? What security controls can we put in place to make that as difficult as possible? Abuse stories. I don't know if anyone's come across this idea before, but I really like it. I don't like Googling it. It's really weird to have abuse stories in your browser history, but it's a really, really good technique for trying to embed security and to think about security up front. I would say to organizations to try and read your previous pen test reports and understand anything that might be common throughout it. Maybe there are a set of libraries that are vulnerable, quite common, or maybe there's technologies that you guys aren't using correctly. If we read the previous reports, we can try and understand that and put in controls to make sure those things don't keep happening. And training, of course. If we train the developers correctly, then hopefully there's going to be fewer issues. People will start to understand security kind of at their core. Like I think a lot of us in InfoSec, we get security, and we need to try and help other people do the same thing. And I will say this is where really we should be in InfoSec. We should be helping. We should be coming in at this point, at the beginning of the development process, and not at the end, as we traditionally do in a pen test. Each of these things can be full talks on their own, so we're only going to look at some of these. So, as I said, abuse stories, I really like this idea. So what we want to say is like a user story in Scrum. We're going to say, as an attacker, I want to perform some kind of action. I want to log into the application without knowing the password. Maybe as an attacker, I want to try and get some free stuff, right? It's an e-commerce application. I want to change the ranking of specific products. Maybe I want to try and say, okay, this is a really cool product when really, it isn't. It's something I'm trying to just flog. Or maybe I want to read some sensitive files. So these things can be broken down even further, and we can say, as an attacker, I want to log into the application without knowing the password. How might we do this? Well, we can brute force the password. If we don't know the password, but we can try and guess it, then that's a valid attack. maybe SQL injection, so we don't need to know the password at all. Password reset of a user. You know, if we can change their password to something that we know, then we don't need to know their original password. This list, of course, is almost endless. I'm sure you guys are thinking of 100 other ways we can try and get into the application this way. This will be a brainstorm exercise. So we sit down as a team with the people that are developing the product, with the InfoSec people on the team as well, and try to come up with as many ideas as possible. So these can all be kind of logged and protected against early. And this kind of leads to this idea of security requirements. So I don't see this very often, unfortunately. As software is being built, often there is a requirements document that's created. And the requirements document says what the application should do. It says, the user should be able to buy products and admin should be able to change prices. I very rarely see security requirements. So if we can put those into that document, then we're in a much better position. We can say all web traffic needs to go over HTTPS, or capture answers shouldn't be sent to the user. And once these are in a requirements document, security becomes part of the quality of the application. If the application is being written correctly, then it includes those security requirements. So if we can get those requirements right, we can find design problems early. Right? I like to think of it of like a house versus a bank. A house is quite a difficult thing to secure. I'm not going to really put my super sensitive things in a house because there are bad locks and there are glass windows and the door frames aren't very sturdy. But in a bank, it's probably quite fine because it's been designed from the ground up to be secure. So let's look at the next step, implementation. So we've looked at how we can implement at least some techniques we can use to implement security at the first two stages. So now in the actual programming part of it. Again, training, I think, is super important. Developers should be trained to write secure code. They need to be sent on courses to learn to do that. Pairing, now this is a really, really cool technique where we have two developers working together on the same bit of code, maybe sitting at the same terminal as well. If one of those developers understands security, they'll be able to influence what the other one is doing and make sure that security is kind of being integrated into the code as it's being written. Then as those pairs split up and move into other pairs, that knowledge is going to follow them around. So you can go from having one guy that's really good at security to it kind of infecting the whole team almost. The idea of a security SME, I think, is quite important. If we can have maybe fewer pen testers and actually have these guys, instead of working externally, bring them into the team, have them as full-time employees inside a company, inside a development team, then there's going to be some security knowledge that is there. The developers have someone that they can answer their questions. They have someone to answer their questions and provide guidance and feedback as they're writing their applications. This is quite similar to Security Champion, but I'd say with a Security Champion that there's someone actually writing the code themselves. It might just be that one guy that is really into security. I'm sure if you spend any time with any development team, there's always that one dude that's just kind of a bit too into security. I know because I was that guy, right? So I used to be a software engineer, and unfortunately where I worked, they didn't let me do security things, so I left to become a pen tester. And I have lots of friends that have very similar stories. So instead, maybe we should say, these guys are here, they're developers, they're on our team, they're interested in security. Let's let them be the ones that are doing security things. Companies should be sending these guys to conferences, for example. They should be encouraging them to do security stuff and keeping them in the teams. Code review, also a really awesome technique for making sure things are developed securely. When I was a software engineer, we did code review when we committed our code into our source code repo, but no one really looked at it from a security point of view. There's always things like, is the code testable, or is it one of these other measures of quality? But there was never really a security thing. Is anyone familiar with the term chat ops? One person, a couple of people? Okay, awesome. So I thought this was really cool. I spent a bit of time doing as an internal pen tester for a company. We're a very small team. There was only, I think, 5 of us, and it was a massive dev team, like all these different projects. And one day, I realized that the devs were talking on Slack a lot, and I said to my colleagues, how come we're not on Slack? They said, oh, we don't really need to be. If they want to ask us questions or whatever, they can email us, or there's Skype for Business, or they can phone us. And they're just doing like dev stuff on Slack. I was like, okay, fair enough. But I joined anyway because I kind of wanted to see what kind of things they were talking about. And I answered more security questions on Slack than I did through any other means. And it was just like random stuff. Devs would just be talking amongst themselves and say, oh, does anyone know how to do this thing in this library? Or does anyone know if there's any like security risk involved with doing this particular thing? And just being involved with how they were talking and talking with them, actually I think made a massive difference to them. And then finally, I would say conferences, right? So not only should we be more accepting of non-InfoSec people in InfoSec conferences, we should be attending fewer InfoSec conferences and more conferences around development and QA testing. So this is something that I've been doing quite a lot recently. I've been trying to go to other conferences, and honestly, it's really awesome to be able to be the security guy there because they have so many questions and no one they can really answer those. So by being there and actually kind of telling our message to them, then they will start to take that on board. As I mentioned before, developers have their own way of testing their code, and unit testing is one of them. And I very rarely see security unit tests, but there's been a lot of effort involved in trying to understand how to unit test code well. So let's try and get security added to that. And there are a few different techniques. There's test-driven development and behavioral-driven development. So let's try and kind of latch onto that. And potentially have the idea of one developer writes the unit test and the other one writes the code. So there's kind of some kind of separation there. So with the unit test and with this behavioral-driven development approach, I like doing this. With my requirement, like I say, given an attacker can submit a username and password, when they try more than 5 incorrect passwords, then the account should be locked, right? And this is a very simple test, but if it works, then it means that as a pen tester, I don't need to now write, usernames can be brute forced and things, passwords can be brute forced. So, I tried to write a very basic test for this. Now, this is very naive, and it probably won't work in the kind of ways we want, depending on kind of how the test is implemented and where the sessions are stored and everything. But you can see, what we do have is a test that says, given a user can submit username and password, so we can have the login authenticator class, and we can try and log in a few times, and then we check if it's been locked. And if this is now in a unit test, every time the software is built or compiled, this test will run, and we know that that is always going to be true. And if that ever stops being the case, then it's flagged instantly to the developer. So, okay, awesome. We've looked at requirements, design, some implementation stuff. What about testing? Now, I don't mean security testing in this case. How can we embed security testing into the QA testing process? Well, I think that security tooling is really not where it should be. Security tooling is fantastic for security people. We have so many awesome hacker tools for hackers, right? SQL Map, Burp Suite, all these tools are awesome. But have you ever tried to teach someone to use Burp Suite? Right? It's really, really hard. I think we forget that because we've been using it for so long. We think, oh yeah, of course it's really simple, but this isn't really how developers and QA testers want to test their applications. I remember one company, they had this open source pen testing tool for mobile applications. And it worked really, really well, and I used it a lot. And then they tried to sell a pro version of it, and nobody bought the pro version. Because what they did basically is they just added a GUI on top of the command line version, because there were just the assumptions that devs, they wanted to do the same stuff, but they weren't quite as smart as us pen testers. So just add a GUI to it, and then that's what they're going to want to use. That's not quite right. So we need to start to write more tooling for these people so that they can actually, so we can take our knowledge and embed it into what they do. And I think a lot of the tooling should now start to look a bit more like this. Things that can be plugged into the build pipeline, things that can be run on a trigger. So like when an application is built, then it runs a load of security tools and gives them instant feedback. It will say, this thing was secure or it's not secure. These vulnerabilities exist. Sure, it's not going to pick up everything, but it's going to pick up a lot, and it gives feedback to the developer and to the tester. So quite naively, I tried to write something like this. This was actually a few years ago for DevSecCon. So we took some of these Android tools and we wrote wrappers around them and we plugged them into Jenkins, and it actually worked really well. We could build the application, and when the vulnerabilities existed, the build would fail. And when it didn't, when the vulnerability didn't exist, the build would pass. So we have a way to see instantly, okay, these vulnerabilities do exist or they don't exist. And again, it's about this instant feedback, right? And yeah, it was not too easy to really write these kind of wrappers, but that was the only real way of doing it. Now we've actually expanded on that idea at Digital Interruption. We've created our own Android testing software, and actually it's mostly run by an API now. So we have a web front end for it, sure, but it's just using the API in the background. So that way we actually have the plugins that will plug into Jenkins or any other CI/CD system that allows us to just run these scans and provide feedback to the developers. So this is just an example of tooling, but this is, I think, what in InfoSec we should be making our tools look like. There are a few different ways of doing security tooling. So we have SAST tools. So these are the ones that do kind of source code scanning. They look for, maybe they do pattern matching, or they do something called taint analysis, where we look at the input that's coming into it. So this is the source and this is the sink. We follow that through. Okay, there might be SQL injection. So it does these kind of things to try and find vulnerabilities. A guy called Nick Jones did a really good talk at DevSecCon on how this works. But yeah, this is a really, really awesome way of performing some kind of security scans as you're writing code. SAST has the advantage of being able to run on the developer's machine, for example. It can be built into the IDE, so as they're typing code and as it's found to be insecure, it gets highlighted in red in the IDE, giving them, again, instant feedback. DAST, this is more the dynamic stuff, so think something like Zap, right? So this is actually running against an actual live application. It can be almost harder than static testing in a way, because we need to have the live version of the app running. It needs to be, the test case needs to run against the actual live version of the app. So it can be a bit harder to get set up. And once the tools are made application aware, this can be quite a powerful technique. And yeah, I've seen that this can be a little better in finding some design flaws, especially if you have given the tool knowledge about the application. And you're using custom rules and custom test cases. And then IaaS, this is quite a new thing. This is like the new kid on the block, really. It's almost DAST with instrumentation. So it has almost the advantages of neither, but the disadvantages of both DAST and SAST. But it's quite a cool technique. So what this will do is it will take your live application and it will inject itself into the runtime of the app. And so as people are using the application or as test cases are running against the application, it's actually doing security checks. So you don't really even need to write particular security test cases or anything, but it picks up security vulnerabilities. Now, the disadvantage is it really only finds the same types of issues as SAST does. But it's just another way of doing it, another kind of bow in our, another just method of doing it. So awesome, we have automated security, right? Not quite there yet. So we have some of these tools, and they work really well. But actually, I tried to do a bit of an analysis of some of these. So I took HackerZone, which is an open source vulnerable application, and I run Burp Suite and Zap against it. And Burp took 5 minutes to run and to find the number of vulnerabilities. Zap took around 38 minutes. And actually, I tried the new version of Burp Suite, and that took 15 seconds. But that's because it couldn't actually run against the app. It couldn't find anything. So it's really naive to say, okay, we have these tools, just run them, and you're good to go. These tools really do need to be configured properly. And again, I would say that this is a really good point to approach our organizations and to say, as the security experts, we're going to help you set these tools up. We're going to, set them up so you are getting as much coverage as possible. So I actually ran it against JuiceShop as well, which is kind of what I'm basing, this Talk Squared company on. So this vulnerable application called Juice Shop. I ran it against that, and honestly, the tools, they crashed before they even found any vulnerabilities, because Juice Shop is a more modern application, and yeah, these tools just weren't quite configured to scan that type of app. They can be configured to scan it, and again, it's just about us in security helping to get those things set up, and not just saying, just run Zap and you'll get some stuff. These are the kind of things that we can find, though. We can find things like cross-site scripting and SQL injection. So on one side, so on the left here, this is from Burp, and on the right is from Zap. So they do find different kinds of vulnerabilities. But again, these are things that could easily be found and should definitely be found before the pen test. I should never be in a position where I'm reporting cross-site scripting, because these tools will find it for you. And also, just because it's easy to find, it doesn't mean that it's a low-risk issue either, right? So there's this idea of like low-hanging fruit. It can still be a high-risk issue and still be low-hanging fruit. So things like SQL injection and XML injection. So QA testers, I found, are actually really, really good at automating what they do. If you've not spent any time around QA testers, I'd highly recommend it. They've been doing some amazing work in how they actually automate their test cases. I guess they're probably more lazy than we are. But they have like such awesome frameworks and techniques to automate their tests. So if we can plug security into that, it'll be even better. Unfortunately, I hear a lot all the time, security isn't our job from them. I think it's up to us to try and convince them that actually a security vulnerability is also a bug. So you guys go and find the bugs. And we looked at this idea of these security requirements earlier. If we have our security requirements laid out, we can actually say to the QA tester, just make sure these things do or don't exist. You don't need to be a security expert to test some of these things, especially if the tooling is good. You can say to the tester, make sure that all the web traffic goes over HTTPS. And again, this is one fewer thing that I then need to put in the pen test report. And actually, I got this message a little while back from a QA tester. I was at a conference called Test Bash, and this is a QA testing conference. And I was there. I gave a workshop on mobile security, but also I was just there to just talk to people about security. And then a little while later, one of the testers messaged me, and they said that they actually found their first vulnerability in one of the applications that they were testing. That was quite a basic thing for sure. It was just sending, the app was sending the password over HTTP to the API. But again, it's awesome, right, that they're finding that before it even gets to the point of needing a pen test. So infrastructure. If we looked a lot about application stuff, and then what about the infrastructure? Because a lot of time that can be the problem, right? Maybe a dev spins up some Jenkins server, and they shouldn't, and then the attacker gets in that way. Well, one thing that I really like is this idea of infrastructure as code. So there are projects like Chef and Puppet and Ansible that lets us write config files and source code to describe our infrastructure. Then that gets run, and that brings up our environment. If we can get to a position where we're doing this, then we can use the same kind of SaaS tools against our infrastructure, because it's now source code. We can say, there's this config file that says, port 22 is open, and that's fine, and that's a good baseline. If that's ever changed to open up port 23, then that could be flagged and highlighted by our build system and say, well, actually, there's a vulnerability here. This needs to be approved or needs to be changed back. When we can't use that kind of SaaS tools, then again, we can kind of use some of these more dynamic stuff. We can use things like Nmap and Nessus, but they need to be scripted and plugged into the pipeline and run continuously. So we actually changed the build system to be something a bit more like this. So the developer, they commit their code to GitHub after doing maybe some security code review. Then that starts off the build with Jenkins. Then it goes through and then just runs all these test cases. It checks for vulnerable dependencies. It checks the source code to find some issues, or it runs dynamic tests. And then only if all those things are successful, then it actually deploys the new version of the application and reports back to the developer. The build can fail at any time. If the dependencies are vulnerable, then it should go back. It obviously shouldn't do the rest of the test and just say to the developer, these dependencies are now vulnerable and needs to be fixed. And of course, this happens or can happen every time the application is built. The reality is that it probably won't happen every time the app is built. Maybe something like this only happens once a week in order to kind of speed up the process. But for every company, they should decide what is important to them, how much security risk they want to take compared to how long they want their project to take to build, and they can decide themselves kind of how to manage this. So we have more of this continuous thing. We say, we're moving testing to be a continuous thing. Development is continuous. It's going directly into production maybe. And the question really is, where does pen testing fit into this now? Because when we do a pen test, we do need a finished application. I've tried to do pen testing in a crazy agile environment, and it's really, really difficult because the app just keeps changing. You find a vulnerability, the next day you find out that they've just removed the code. Right, so we need to finish that when we're doing pen testing. So again, when we looked at this, we said that maybe if it's in the bottom left-hand side, we don't need a pen test. And I would say, if we have all this security that we've automated and add to the build and to the process, then it's totally cool to go live without doing a pen test if it's a low-risk application. If it's a high-risk application, okay, we probably still need a pen test, right? So I'm going to say something a little bit controversial. If you don't want to hear that, feel free to block your ears. What I'm going to say is that if we're now in a position where we know that the baseline of the application is secure, actually maybe a tick box pen test is okay. Now, I think it should definitely have a different name. It shouldn't be called a pen test. But to have someone manually going in to just review the application and say, all these tools that we're running, they are actually working. Have someone manually go in and check for, cross-site scripting and SQL injection, the things that are easy for them to look for. And now this isn't really the process of trying to find awesome new vulnerabilities, but just kind of verifying that things are working correctly. And I call this, more like security verification or something. And you can decide to do this maybe once every X number of releases, or maybe after a specific change to some things. Now, I think that this will kind of try and help with some of the skill shortages that we're seeing in InfoSec. It will say, because this will be kind of more entry-level work, so more people can be doing it. It can be embedded into the organization a bit better than we do in pen testing. So again, depends on the risk of the application. You might decide that actually, you know what, all the tools are cool and they're always running and that's awesome. We've had every 3 months, a manual person going in and just reviewing everything and making sure that nothing weird is slipping by, which honestly leads to this, which is kind of where I would see myself more as someone doing kind of a proper pen test. So it might be for those super high-risk applications or high-risk industries. We actually have now the pen tester that's free to test, in production against a number of their applications, trying to find that one edge case, that one vulnerability that actually has business impact. So no longer am I reporting all these low-risk issues because by this point, hopefully, they should all be fixed. I get to spend my time looking for the one thing that's actually going to lose the company money. With all these things, they should feed back into the organization. I really hate this thing where we just send PDF reports of our pen test. Instead, I would like to see all this data from all these tools and from things like red teaming and security test cases all going into some central repository. And once it's in that repository, that's what the build systems can use to decide whether the application is okay to go live or not. That way we are adding in some of that human element and the things that humans that we're good at finding the tools aren't. We're adding that into the process as well. This also allows us to make it a bit easier to do regression testing because a pen test is a point in time, right? If we move to more something like this, the tests are much more repeatable, and they can, if the vulnerability comes back in at a later point, this kind of approach will hopefully pick that up as well. So I've had some people say this to me, that's not going to work. So I've tried to think of some of the objections that some pen testers have kind of raised, and one of them is you need to be super elite to find like some security vulns, and that's just not true, right? To exploit them, I would say things are different. But to find them, sometimes it's just a case of putting a tick box in a field and pressing enter. So to find the vulnerabilities is not the hard thing, and that's what we need to make it easier for other people to do, to find vulnerabilities. Again, a lot of the tools that we've created for ourselves are really good at exploiting vulns, but we just need the tooling and the methodologies to just find them. Automated tests won't find everything. Honestly, nor does manual testing. I might be doing a test and maybe I'm just quite tired one day, or maybe, and I've seen this before, where a junior pen tester is sent to do a pen test. Manual testing doesn't find everything either. So if we're not going to find everything, at least let's try and automate as much as we can. So you need a pen test to be secure. Fixing vulnerabilities makes you more secure. If more vulns are getting fixed with this kind of automated process than it is with pen testing, then maybe that is actually the better approach. But yeah, doing a pen test is not the thing that makes a company secure. And then bug bounties for life. Bug bounties are awesome. Like, they are a really, really awesome technique. But they only really work when an organization is mature. If they're not doing some of this other stuff, then it makes no sense for them to run a bug bounty. They're just going to spend way more money doing that and if they would have just taken that money and applied it to some of these other things, they would be in a much better position. So I'm not really good at starting talks, and I'm not really that good at ending them. So I'm just going to quick summary. We want to make pen testing great again. Pen testing used to be super fun, and then it just became doing the boring web apps. Again, I never want to be in a position where I'm finding and reporting cross-site scripting. Companies need our help, right? InfoSec needs to kind of put the ego aside and realize that we are actually trying to help these organizations too. We're part of the process. And let's just automate as much as we can so I can find those one or two things that are super interesting. Thank you.